Good morning, dear students. A warm welcome to all of you for today's digital revision session for the subject Science and Technology Section A. Yesterday, we have revised chapter number 13 from Section A, Carbon, an Important Element. Today, we are going to revise chapter number 12, Study of Sound from Physics. This is our second revision for the chapter before the third assessment, which is going to start from 10th of January. Let us begin with the revision of all concepts related to sound. Sound. As I had informed you in the beginning, what does this term or word sound mean? In physics, sound is nothing but a form of energy which creates the sensation of hearing in our ears. And this energy is in the form of waves. For the propagation of this sound waves, always a medium is necessary. The medium may be a solid medium, liquid, or a gas. But sound waves cannot ever travel through vacuum. Now, the two types of waves which we are going to study is, the first type of wave is longitudinal wave. What do we mean by a longitudinal wave? When the particles of the medium oscillate about their central or mean positions in a direction parallel to the propagation of the wave, then such waves we call as longitudinal waves. Or in simple words we can say longitudinal waves are those waves in which the particles of the medium move parallel to the propagation of the wave. And sound waves, the main topic of the chapter, sound waves are nothing but longitudinal waves. On the other hand, the next type of wave is a transverse wave, a wave in which the medium vibrates at right angles to the direction of its propagation is called a transverse wave. Now, the different indications, how certain terms are indicated which are related to sound. Now, when I have told you that sound moves in the form of waves, then you know wavelength will surely come into consideration. So, wavelength of sound waves is indicated by the Greek letter lambda and frequency is indicated by nu. Amplitude, which is the maximum value of pressure or density, is indicated by capital A, and time taken for one oscillation of pressure or density at a point in the medium is called the time period and it is indicated by capital T. In the earlier chapters, laws of motion, we have seen that time is indicated by small t, whereas for a sound wave, the time is indicated by capital T. Next topic is velocity of sound. In the earlier chapters, we have studied what is speed, what is velocity. Velocity is the displacement per unit time. So here also for a sound wave, the distance which is covered by a point on the wave in unit time is the velocity of sound wave, or in other words, in simple terms, we can say that velocity of the sound wave is distance upon time. As you know, 1 upon t is equal to nu. So, velocity v is equal to nu multiplied by lambda, that is wavelength. So, velocity is wavelength upon time period. So, wavelength indicated by lambda, time period by capital T. Velocity of sound is equal to wavelength multiplied by frequency. Why wavelength multiplied by frequency? Because 1 upon t is equal to frequency. So, the simple formula for velocity of sound is wavelength multiplied by frequency of the wave, and you know you have to utilize this formula in solving the numerical examples. Now, if you look at the velocity, this velocity is highest in the solid medium and medium in the liquid medium and least in the gases. Ahead you have one fill-up which is related to it. So you should know how the velocity of sound differs according to the medium. Next, now we are going to study about the velocity of sound in a gaseous medium. First, you know that the velocity of the sound in a gaseous medium, it depends on the different physical conditions such as the temperature, density and molecular weight of that gas. Now different conditions are there for different physical conditions. For the first one, that is temperature, the velocity of sound is directly proportional to the square root of the temperature of the medium. Directly proportional to the square root of the temperature. You can see velocity directly proportional to the square root of temperature. What does this mean? Increasing the temperature 4 times doubles the velocity. For density, velocity of sound is inversely proportional to the square root of density. For molecular weight also it is same. Velocity of sound is inversely proportional to the square root of the molecular weight of the gas. So V inversely proportional to the square root of density, V inversely proportional to the square root of molecular weight. So what does this mean? That increasing the density or molecular weight 4 times reduces the velocity to half of its value. You know you have different numerical examples where these conditions play a major role. Now our next topic is very interesting topic. The different types of sound and the range which decides the nature of the sound. The name of the topic is audible, infra and ultrasound. Audible, infra and ultrasound. As we know that sound which is being produced within a certain range can be heard by human beings. So the limits of hearing of the human ear are in the range between 20 Hz to 20,000 Hz. What we can say here, the human ear can hear the sounds of frequencies in this range, and these sounds, they are called audible sounds. Why audible? Because the sound which falls in between this range can be heard by us. Now, sounds which are less than 20 Hz or more than 20,000 Hz cannot be heard by human beings, and there are names for these two types of sound. So sound with frequency smaller than 20 Hz is called infrasound, whereas sound waves with frequency greater than 20 kHz or 20,000 Hz are called ultrasound. There are certain animals, even children under 5 years of age, there are some creatures, some insects which can hear the waves with frequency up to 25 kHz also. I have given a very good example about bat, or I had told you about the birds or the animals which become alert before an earthquake strikes. So whatever changes occur below the earth's surface, that small sounds can be sensed by these animals. They do not know how to react, and then they just start running or barking, or the birds start, you can say, shouting or chirping in a very different way to express their reaction towards the sound which is emitted. They can sense that something different is happening, but they cannot express it. About the bats, we had seen how bats can travel during the night time without colliding with any obstacles in its path. Now, how about the ears? How you can say that the ears of the bat do not function? It was invented by the Italian scientist Spallanzani. He was the first to discover a special mechanism present in the bats. What he did in this experiment was, this is just for your information, he covered the various organs of the bats like the eyes, ears, nose, etc. one by one, and then he allowed them to fly in the dark, thereby discovering how they can fly easily in the dark. One by one, he covered all the organs. the eyes, then the ears of the bat, the nose, and then he allowed them to fly in the dark. He found what he observed was that the bats with their ears covered began to collide with whatever came in their path. Even though their eyes were open, their eyes were of no use to the bats, and thus he reached a conclusion that their ability to fly in the dark, it depends on their ears and not their eyes. For us, for animals, they can see with their eyes if any prey, any obstacle is there in their path, and they can change their path. But these bats, they emit the ultrasonic waves which travel through the air, hit any object or any obstacle which is there in the path, and the reflected wave is again coming back towards the bat, and from the time interval between the transmission and reception, the bat comes to know about the situation in its surroundings, and if the time interval is less, then the bat knows that there are some obstacles in its path and it changes its way, it changes its path. Now the uses of ultrasonic sound. Now this topic is removed out from the syllabus, but just for your information, there are various uses of this ultrasonic waves. They are used for communication between ships at the sea. Very important is the echocardiography technique or the ECG, which studies the heartbeats. It is based on ultrasonic waves to obtain the images of internal organs in the human body, or to locate the cracks, the faults in the metal blocks. For all these different purposes, ultrasonic sound, all the ultrasound is used. Our next topic is about echo. What is an echo? What phenomenon it is from physics? Forget about physics. In simple words, I will tell you that an echo is a sound that is repeated because sound waves are reflected back, or when sound waves hit a hard surface, they might reflect, making the, sound bounce or come back. And to hear this echo, there are certain echo points at hill stations. If you shout loudly at such a point, then you will hear the same sound just after a little while. So what is this echo in physics? It is the repetition of the original sound because of reflection by some surface. Now there are certain conditions for an echo to be heard. In order to be able to hear the original sound and its reflection very clearly, very distinctly at 22 degrees Celsius, the velocity of sound in air is 344 meters per second. Thus, now you know that our brain, it retains a sound for about 0.1 seconds, and hence for us to be able to hear a distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and then come back to the human beings. So how you can determine the minimum distance between the source and the reflecting surface? So distance, you know the formula of speed, distance upon time. So to calculate the minimum distance, you will use speed multiplied by time. Speed or velocity is 344 meter per second. Time I have already told you 0.1 seconds. When you multiply, you will get 34.4 meter. So to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above value. Half means 34.4. If you divide by 2, you will get 17.2 meters. So if you want to hear an echo very distinctly, very clearly, then the reflecting surface should be at a minimum distance of 17.2 meter, and this condition is not satisfied in the classroom, and hence we do not hear the echo of the things which are spoken in the classroom. Exactly the other undesirable phenomenon related to reflection of sound is reverberation. Before we go ahead to reverberation, certain photos of echo points I have put, just you can go through it. Apart from this, if you search in the Google net, you will get n number of photos of eco points. This is the eco point at Munnar in Kerala, eco point at Matheran, eco point at Mahabaleshwar. So this eco points are the places of tourist attractions and which attract more money for the people in the local area over there. Reverberation. What is reverberation? Reverberation means when sound waves continue to vibrate after the original source of the sound has stopped emitting the sound, that is called as reverberation. So sound waves, they get reflected from the walls and roof of a room multiple times, which causes a single sound to be heard not once but continuously, and this phenomenon is called as reverberation. Now, this is an undesirable you can say phenomenon, so you have to reduce it, you have to put a check or control on this reverberation. So how you can control it is by making the ceilings of the halls curved, or the auditoriums, the theaters, they should have curtains which should be of sound absorbing materials, or carpets should be of sound absorbing materials. The seats for the theaters, auditoriums, they should be of such a fabric that it should be sound absorbent material, so the excess sound can be absorbed and whatever is required, that only will be heard, and reverberation can be, you can say, checked or it can be controlled. Our next very important topic is sonar technique. How this technique works, I have told you the very first use of ultrasound for communication between the ships in the sea. Let us see how this topic is linked with this use. Sonar. Sonar is the short form for sound, navigation and ranging. SO stands for sound, N stands for navigation, A stands for and, R stands for ranging. Now this technique is used to determine the direction, distance and speed of an underwater object with the help of this ultrasonic sound waves. Now, how does this technique work? It has a transmitter and a receiver which are fitted on the ships or the boats. What is the function of the transmitter and receiver? The transmitter, it produces and transmits the ultrasonic waves. You can see here an arrow in the downward direction. These waves, they travel through the water, strikes any underwater objects which are there and get reflected, and then the waves are received by the receiver. You can see the arrow in the upward direction. Now if the diagram is asked in the exam, I don't want artistic boats and all. A simple boat, show a transmitter, receiver, then the transmitted waves with the arrow in the downward direction, received waves with the arrow in the upward direction, water, transmitted pulse and reflected pulse. Now this receiver, what is the function? It converts this ultrasonic sound into electrical signals and the signals are properly interpreted. Once the receiver, it receives the reflected waves, or you can say not waves, the pulse, it will convert this sound into electrical signals, and the time interval between the transmission and reception is noted down. By knowing the time interval and the velocity of sound in water, we can easily find the distance from the shape of the object which reflects the waves, and hence this technique is used to determine the depth of the sea. Not only that, it is used to search underwater hills, valleys, submarines, icebergs, sunken ships, etc. etc. You know how the Titanic ship, it had sunk into the sea because at that time such techniques and all were not discovered. Our next fruitful technique based on ultrasonic sound waves is the sonography technique, which also makes use of the ultrasonic sound waves to generate the images of your internal organs of our body. This technique, it is used for finding out the cause of swelling, infection, pain, etc. Not only that, the condition of our heart, the state of the heart after a heart attack, as well as the growth of the fetus inside the womb of a pregnant woman are also studied by making use of this sonography technique, and this technique is very painless, hence effectively used and appreciated by the public and very useful in medical science. How this technique works? It makes use of a probe and a gel. This is the probe. Why the gel? This gel, it is used to make the proper contact between the skin and the probe so that the full capacity of the ultrasound can be utilized. Where this gel is applied? It is applied outside the internal organ which you are going to study. Whether you are going to study about the heart, about the kidneys, about the liver. So outside part of the body, below it where your organ lies, the gel is applied. The high frequency ultrasound is transmitted inside the body with the help of this probe. Many of you might have experienced the sonography technique. The sound reflected from the internal organ is again collected by the probe and fed to a computer which generates the images of the internal organ, and then the doctor analyzes or finds out what actually problem the patient is facing, the patient is undergoing. This technique is used for the proper diagnosis of your organ of the body, or it is used to find out the condition of your heart, the condition of the fetus inside the mother's womb. So if any abnormalities are experienced, then the doctor can go ahead with the different steps, or other different medications and all can be suggested in a very proper manner. But this sonography technique, as we know that each coin has two sides, so this technique can help to follow the growth and well-being of an unborn baby, but the increasing incidence of female feticide, you have heard especially in the rural areas, if the person comes to know that the fetus inside the mother's womb is a female, a girl child, then child killing is carried out. Although it is illegal, but it is practiced on a large scale in the rural areas. So as a result of the discrimination between the girl and the boy child, it is an example of the disadvantage, the misuse which is made of this technique. It is a grave misuse of this technique. The last topic to end with the revision of this chapter is, before that, see the different images. I have put different images related to sonography of the heart, then ultrasonography of kidney. The last topic is the different parts of the human ear. As the name of the chapter is study of sound, and sound is a form of energy which creates a sensation of hearing in our ears. So it is very necessary for us to study the different parts of the human ear. As you all know that it is an important organ of the human body, we can hear the sounds generated in the environment around us because of our ear. So when the sound waves, they fall on the eardrum, it vibrates. These vibrations are converted into the electrical signals which travel to the brain through the nerves. So how this entire process works out, that we are going to study by studying the different parts of the human ear. Now, our human ear is divided into three parts. The three parts are the outer part of the ear or the pinna, the part where the girls, they put their earrings. After the outer part you have the middle ear, and after the middle ear you have the inner ear. This is the inner part of the ear. So each part of the ear has a different function. Outer ear or the pinna, its main function is to collect the sound waves from the surrounding and then pass them through a tube to a cavity in the middle ear. Its peculiar funnel-like shape, it helps to collect and pass sounds into the middle ear. So the main function of the pinna is to collect the sound waves from the atmosphere and then pass it to the middle ear. The middle ear is nothing but a thin membrane. In Marathi you say kanacha padda, which is very delicate. It is a thin membrane in the cavity of the middle ear, and this is called as eardrum. You can see the eardrum. How this eardrum functions? When the compression in the sound wave it reaches the eardrum, the pressure outside it increases and it gets pushed inwards. Exactly opposite, when a rarefaction reaches over there, the pressure outside decreases and the membrane get pulled outwards. Thus the sound waves cause the vibrations of the membrane, and then the vibrations, they are carried into the inner ear. Now this is the inner ear. The auditory nerve, it connects the inner ear to your brain, and this inner ear has a structure resembling the shell of the snail, which is called as cochlea. See, it looks like the snail which is seen in the rainy season. The cochlea, it receives the vibrations from this thin membrane, which are received from the membrane, and converts these vibrations into electrical signals which are sent to the brain through this auditory nerve. And what is the function of the brain? The brain analyzes these signals, and then we can hear the sounds as it is. As it is a very important sensory organ, the eardrum is also very delicate, so sticks or other pointed objects should never be inserted into the ear for cleaning. You know that cotton buds are available in the medical shops that you can make use for cleaning your ear. Also, we should not hear very loud music using the earphones. Nowadays, we see children at a very young age, adults, they continuously make use of these earphones. Maximum of the time their ears are occupied with these earphones. This sound is extremely dangerous not only for your ear, but it can cause a permanent impairment of your brain, a damage to the brain also. So you have to take care of each and every organ, which is a blessing given to us by God. You come to know about the real, you can say, price of each and every organ, the importance of each and every organ when you see people around you who are deaf, people around us who are blind, people around us who are dumb. So when you see them, then you come to know about the importance of each and every organ which is received to us by God in a good state, and now it's our duty to take care of them. And also another duty for you is now you have to take care of the exams by reading each and every topic, going through each and every diagram, practicing the numerical examples, the different formulae, and will be attempting your exam whether offline or online in a very serious manner. So best of luck from my side. Be safe and be at home maximum time wherever possible. Do not move out of your houses for unnecessary reasons, and at the same time keep a check and control on your studies. Thank you, dear children.